Hello, welcome to AT&T ThreatTraq for February 16, 2017. This program provides network security highlights, discussion, and countermeasures for cyber threats. We're joined online today by Jim Clausing. How's it going, Jim?
Going well, going well.
All right, glad to hear it. Also here on the couch today, we have Stan Nurilov, one of our expert malware analysts. Stan, how are you doing?
Doing well, thanks, Matt.
Cool. Working on anything interesting these days?
I'm always looking at something exciting, reverse engineering new types of malware, and of course the Mirai botnet and similar kinds of IoT malware have been keeping me busy.
Cool. Very interesting work.
Yes.
I look forward to hearing more about it. My name is Matt Kaiser. Our first story today will go to Jim. And Jim, this is an interesting one, a little bit of Ocean's 11 sort of slant to it. Why don't you tell us a bit about it?
Yeah, I actually first picked it up on the Schneier on Security blog, but he was referring back to a Wired article. It appears that a group of Russian hackers have reverse engineered the pseudo-random number generator in a particular brand of slot machines. And so what this allowed them to do was send somebody into a casino to, play the slots, and by getting a sample of the numbers that came up on the slots, basically just taking pictures with their cell phones. They send this stuff off to St. Petersburg, where they've got some computer running there, who analyzed it, figured out the seed basically for the pseudo-random number generator, and then was able to send signals back to the cell phone of the person sitting at the slot machine, telling them when to hit the buttons. By sending the signal about a quarter of a second ahead of the time that they need to hit the button, that's about human reaction time. So they were able to basically beat the slot machines. It was first detected in 2014, some accountants at a casino in St. Louis who noticed that for a couple of days, a couple of slot machines had paid out a whole lot more than they should have, under normal circumstances.
So, sorry to interrupt you, but they gathered the data in order to do this only from taking screenshots using their smartphone cameras, or did they do research beforehand to kind of get an idea of how the pseudo-random number generator worked?
Somebody figured out the algorithm for their pseudo-random number generator. Somebody in this group in St. Petersburg figured that out. The algorithm for the pseudo-random number generator is hard-coded into the hardware, or in at least it's in the slot machine itself. So it may be software, but it's difficult to update the algorithm. So the key is by just taking some video or some pictures with their cell phones, they were able to get enough data to figure out the seed for that particular slot machine. Mm-hmm. And then they could predict what the random numbers that the algorithm is going to generate in time to tell the user, okay, hit the button now, hit the button now, hit the button now. And it's actually in a nasty way kind of an ingenious thing for them to do, but it's also extremely difficult for the companies to fix the slot machines, because there are thousands of these slot machines, or maybe millions. I'm not sure how many slot machines are out there, but the pseudo-random number generator is in firmware or in some software in the slot machine, and to fix it you actually have to go to each physical slot machine. It's not like slot machines are on the internet. You wouldn't really want them to be, so that they could do a network push to update everything. So it's it's kind of a nasty issue, and the casinos at the moment have no way to fix it.
So what is there? Do they have a temporary fix in mind, or are they just shutting those machines down until they've got something better they can do?
I'm not sure what they're doing.
I figured they have to rely on physical security like they always do, prevent people from taking pictures and stuff like that. And it looks like they have a pretty good analysis team, Even the accountants are good analysts over there in the slot machine department.
Sure.
Obviously, to have noticed something.
Well, the accountants keep track of these kinds of things.
Right.
I mean, that's, a casino's business is based on, the folks coming in to bet, betting more or, spending more, dropping more in the slots than what gets paid out. I mean, that's the only way the casinos stay in business. And so they have, they've got a pretty good idea of what percentage of the time a given machine ought to be paying out. And when it deviates dramatically from what they're expecting, that gets people's attention.
Absolutely. It's interesting because on this show, if we talk about pseudo-random number generators, it's usually in the context of some sort of cryptographic function.
Yes.
But you can show that this is a direct translation of if your random number generator is out of whack or predictable, that directly translates into money lost.
Yes,
Yeah.
and it's actually one of those things that's very impressive to me, like these mathematical type of exploits where you can predict something and I guess make money out of it or break encryption. These are always very impressive to me because I don't even know how they work.
That's one of those things you wonder about it. You're never going to get a write-up out of these folks as to how they actually achieved what they did, but heck, it would be great to read. Really fascinating stuff.
It definitely is.
Yeah. All right, thanks a lot, Jim. Our next story, I'm going to cover it. It's talking about a new bug called Ticketbleed. You've probably heard of Heartbleed if you've been watching our show. Same guy found it. Filippo Valsorda posted up on his site, filippo.io, and also did a little bit of a write-up on how he found the bug. So this is a bug in the TLS stack of certain F5 load balancers. The bug is in the session ID of a session ticket in a change cipher spec request. And that is getting in the weeds a little bit. But
That
suffice
sounds
it,
complicated
it's a little
for sure.
complicated. And the good part is there's a write-up, so if I'm not making any sense, certainly it's going to make a lot more sense. So I apologize if I am a little bit fuzzy on the details. But what I do understand is the session ID that should be provided by the client to the server is expecting it, and the server in this case being an F5 load balancer, is expecting it to be 32 bytes long because that's what the spec says. It can be, I believe, up to 32 bytes. And the server is supposed to echo that back. But in this implementation, the bug is if it's not full 32 bytes, the F5 load balancer will grab extra bytes of memory next to where that session ID is supposed to be stored and echo them back. So that's why it's called Ticketbleed, because it has to do with the session ticket and session ID. And it's the same sort of mechanism, exposure of arbitrary memory on the device, as the response to a request. So that's
Kind
where
of
the
like
name comes
Heartbleed was.
from. A lot like Heartbleed. Yep.
Okay.
So the good thing is it's limited to F5 load balancers. This is not like an open SSL bug that affects everybody because it shouldn't be quite as much as a patch-tastrophe as the last time. So hopefully if you have an F5 load balancer, they've contacted you and you're working through and getting this set up. If you don't have that situation where you have that relationship with them, I think you can actually disable session tickets, and that'll have some impact on how you do TLS, but it'll be secure. You won't be vulnerable to this sort of memory grabbing attack.
So with this memory grabbing attack, would it be similar to the SSL Heartbleed bug where they were able to maybe try to get the private key out of memory? Would that still be feasible here?
I imagine it would. I don't think anybody's done analysis to say exactly what is in memory that you can grab, but I imagine if you sat there all day, you could gradually leak 31 bytes of memory because you have to send something for it to work. So you send a 1 byte session ticket, you get 31 bytes. You do 31 bytes at a time over time, you can probably explore memory and find some interesting things, but you're going to get that little window. So still,
Yeah,
pretty interesting.
definitely.
Yeah,
A lot can happen in 31 bytes. We all know.
I like that.
It's another example of why crypto is hard. It's the little things like remembering to pad out the size of the buffer that can really bite you.
Yep. And again, this is not a bug in the design of the protocol. This is a bug in the implementation.
No, right, right,
Yep.
exactly. It's the protocols are hard enough to design, but then the implementations, are also you need to be very careful about how you implement them. Yeah.
Yep. All right. So Stan, yours is the next story, and I got a real kick out of this one. This reminds me of some of the old school hacker pranks that used to occur back in the 90s. It's a little more, it's not as malicious and a little more fun to it, I think.
Definitely, but it's definitely something that shouldn't be attempted lightly, right?
Right.
It also reminds me of back when I was learning cybersecurity on my own. So apparently, I think in the UK, this high school student decided one day he was bored and was going to explore vulnerabilities, I guess, in IoT devices. And so he figured he was going to basically send a print job to 150,000 printers in the UK. So when you read the story on Vice, it's actually pretty interesting because it's an interview with this person and kind of asking them, hey, what were you thinking while you were doing this? And why did you do all of these things? But some of the pictures interspersed in there are really kind of clever. He created basically, for some reason, a lot of the printers that are connected to the internet and listening on some of these ports like 9100, I think 631 and 515, they're basically POS systems. For some reason, these POS systems, so the little like receipt printer is connected to the internet. That doesn't make too much sense to me, and I'm sure it's probably inadvertent, but basically these receipts were coming out all day long with pictures of little robots with little messages that say, hey, your printer is now part of a botnet.
Right.
And so I can see how it was clever for this high school student, but I'm sure, it was frustrating to a lot of the business owners who didn't know what was happening.
To be fair, they weren't made part of a botnet. Am I right?
That's correct. So even, when the interview took place, he admitted it wasn't really part of a botnet. I think the interviewer even asked him, so why'd you say it was? And I think you could see that he's a kid, he's messing around, he thinks it's funny, even though it's probably not something to take lightly to just go and kind of do this because of the unintended consequences. I mean, I think a lot of people took it kind of lightheartedly, but not everybody, I'm sure. Imagine if you have, in your local coffee shop, some kind of, you're trying to check your customers out and you can't because these little bot messages, while funny, maybe, arguably funny, right? They're coming out and you're not able to do business. So I think for some people it wasn't as funny as it was for him. I think he was being clever, and one of the things I found touching during the interview is that he mentioned that he didn't think he had an outlet for his skills with all of the things that he was doing. So he mentioned that in high school, he tried to do responsible disclosure on some bugs. And when he did that, people told him, well, don't go snooping around. So they didn't treat his findings in a way that kind of gave him, an outlet or encouraged him in a positive way.
Right.
Whereas, they could have taken that and probably, made him go on the right path. They probably kind of discouraged him. And he was like, oh, well, I'm just going to do whatever I want. So I think especially with young people or people like me, right, when I was young, I also had a lot of ideas. Hey, let me hack away, right? But something inside me told me, hey, there's a line here that you shouldn't cross. And I think as you're learning about cybersecurity, you either need a mentor who's going to help you get through that so you can understand that, hey, it's important to do these things responsibly. Yes, it's good that he knows about these vulnerabilities and he wants to illuminate the problem. And I think he did that, but it's possible he could have caused outages or something more serious. So there is something to be said about not just going and doing things haphazardly,
Right.
Kind of like he did. But it was clever, it was fun. Some of the Twitter pictures were kind of interesting to look at. People were like, wow, I'm amazed who has such skill to kind of commandeer all these printers. I'm getting a kick out of it, but I'm sure not everybody felt that way. And one thing that he mentioned that he thought would have helped him to channel his creativity or his energy was competing in a CTF or something like that. He actually made reference to that. And I find that that's actually would have been something that would have helped him, because I know for me, participating in some of these things like CTFs or challenges or educational opportunities has always helped me to not only kind of like up my skills, but also learn the proper way to like take up my time so I don't do something mischievous.
I know you, Stan. I'm fairly sure you've done a few mischievous things.
The thing that gets me about this, though, is 150,000 printers should not have been accessible on the internet.
Absolutely.
Printers have no business on the internet. They ought to be, and if you're going to offer public Wi-Fi in a Starbucks or whatever, then you need to make sure that your printers and your POS terminals are firewalled off from the public Wi-Fi. That's just the part that drives me nuts here. Is how did we get 150,000 printers in the UK that were all accessible from the internet? Those are not ports that need to be accessible from the outside. You don't offer, printing services to the universe.
Oh, I agree.
Especially on a POS system. I think that was the most shocking thing for me.
Well, I think that was part of it, is that they all seem to be using the same set of protocols. Now, there were 3 different ports that he was scanning. Then he also mentioned he actually had found a vulnerability in a certain Xerox printer web interface and was submitting print jobs through that. So 4 different ways. And it is kind of interesting to see in the Twitter feed the different printers and how they each handled the job, because some of them were printing out on the little, receipt printer. Some of them are full page. Other ones they're all printing in different ways, but they're all getting the same job, which is kind of neat in my opinion. And
I think I discovered this when I mistyped an nmap command on my home network.
oh yeah,
And I was printing out to my printer like little banners from SMTP or HTTP, I forget what now. But yeah, when I was still learning, that's definitely something I discovered you can simply do.
and I agree that these things shouldn't be on the internet. And in a sense, it's good that this is making the news, because people
Yes.
should be doing something to take these things off of the internet. And it's kind of silly. The other thing I found interesting is digging into this more. There's a lot of research that has been done, but not gotten a lot of press until this. And this is not the only case of someone printing to the internet. I think there was a case maybe a year ago of someone printing anti-Semitic messages using a similar situation where these printers were attached to the internet, and that got some press at the time, but since then it's been somewhat quiet. There's also a couple of instances of people printing ransomware messages using the same kind of bug. Now, again, this bug is not used to take over the device. No one has actually hacked your printer. But if your printer starts printing messages saying that it's been hacked and you have to give me a certain number of Bitcoin to get it back, I imagine most users would take that at face value, because they're not even probably aware their printer is connected to the internet and you can just dump bytes into it and get a print job out of it.
Right.
There have been vulnerabilities in the firmware on printers in the past too. This particular case didn't exploit one of those, but there are still a lot of printers out there that have vulnerable firmware that if you have the right exploit, you can actually take over the printer. And, in the past, the issue has been that, you could conceivably get the images of previous print jobs that may have contained sensitive data, and that kind of thing. So that's the other piece of this, that there are printers that can be hacked. In this case, he didn't do that, but that doesn't lessen the concern to keep the printer firmware up to date, to keep them firewalled off from the internet, from public networks. Obviously, in an enterprise, you want the printers available so that the folks at their desk can print to the nearest printer, but you don't want those open to the entire universe.
Yeah. I mean, I think of it a little bit like, black faxing. You've heard of this, where people will send faxes to try and run out the ink. I mean, there's certain denial of service attacks you could run on a printer just by running out the paper and the ink, or you'll start getting these sorts of messages. I remember a previous workplace where every once in a while the fax machine would spin up, and it would be some sort of spam advertisement for some company halfway across the globe, but they had found a way to bridge through VoIP and send fax messages all over the place in the hope that someone somewhere would pick it up and be interested in whatever it was they were selling. So, I mean, if this doesn't get fixed, I can imagine this same kind of situation where all of a sudden your home printer starts printing messages that aren't just some kid playing around, but you've got some sort of
Some kind of
spam message
spam
or some
and
sort of
things like
commercial thing that it's intrusive, absolutely. So anyway, I find this pretty interesting, and it's a story to watch, I think.
Yes, definitely.
So heading on to the internet weather, the top 10 most probed ports for this past week. No surprise at the top is port 23 TCP. It's Telnet, our old friend. 5358 is up there, and again at number 2. We're going to be covering that in the internet weather. 7547, which is TR069, I believe. CWMP, which is a WAN management protocol. 22 TCP, which is SSH. 1900 UDP, which is UPnP, followed by 53 UDP DNS, most likely scanning for the ability to do a reflective denial of service attack, the same for 1900 actually. 3389, which is remote desktop protocol, followed by 1911, which is the Niagara AX. It's a
Tritium Niagara protocol.
Yeah, it's a protocol for managing.
Industrial control system devices.
Thank you, Stan.
No problem.
Glad I have you here. 80 TCP, which is of course HTTP, and then 123 UDP is NTP, most likely again for reflective denial of service scanning.
One quick note on port 53. They may also be looking for
That's right.
unpatched bind servers. There was a denial of service vulnerability that the Internet Software Consortium patched this week. We didn't put a slide together for that or anything, but that's one other thing that they may have been looking for with UDP 53 this week.
That's a very good point, Jim. Thank you for bringing that up. If you are running bind in your environment, it's probably time to take a look at patching it, because that's a pretty significant denial of service bug, and nobody likes that. Again, most sources probing. 23 TCP still takes the lion's share this week. 7547 is in second place, followed by 5058. And then a number of ICMP are also scattered throughout there. 80 TCP, 21, and I believe 445 as well, which is an interesting one. We don't see that one that often. Taking a closer look at some of these ports, port 1911 TCP is the Niagara Fox protocol. In the last few weeks or so, we've seen a number of new IP addresses scanning, which appear to belong to a security research organization. So we're marking this new scanning as benign, but you can see the regular periodic increase in the number of scan flows, I would say probably on a 24-hour basis or so. So this again is for security research into an ICS building automation. So we'll see where that goes. Port 7547 TCP is CWMP, or TR069, goes by a number of different names. This is a protocol used by mostly ISPs to manage their field devices, things like cable modems. It looks like this is typically an IoT botnet sort of scanning there was a bug, I believe, in TR064 via 069. We covered it on the show maybe several months ago. I'm going to say sometime in the December timeframe, which is a very interesting bug. It's a remote command execution bug, pretty useful for building out a botnet if you can find devices that are vulnerable. And scanning is leveled off for the most part, no longer at the heights that we saw back in November and December, but still something to keep an eye on. And you can see there's probably several different botnets doing this. You can see the regular baseline is at a pretty high count, I'd say about 150 million scan flows, and then a couple of spikes on a daily basis. Taking a look at good old port 23 Telnet. This is actually down somewhat from the highs that we've seen in the last year. You can see that back at the start, about a year ago, it was about a half to a third of where it was today. We saw some huge spikes somewhere through September, October timeframe, but it seems to have gone back, but still at the top of our list. Definitely one to keep an eye out for and understanding. If you're still running Telnet in this day and age, definitely something in your environment to take a look at, see if you can minimize the exposure on that. And the big mystery of the week and of past weeks is port 5358 TCP. This is registered as web services for devices, secure. The graph shows 60 days. There was some activity back in around Christmas time through the start of January, but in the last, I would say, month or so, we've seen significant increase in this port scanning. The largest number of the scan sources are in the US, lots of DVRs, embedded boxes. It doesn't necessarily mean that the vulnerability they're scanning for is in an IoT device, but it seems to be something that the people who have these sorts of botnets, possibly other, Mirai offshoots, are scanning for. So, one theory is that this is a bug or an alternate port for Telnet, something that IoT botnets would like to build out. It's also a possibility, John Hogaboom mentioned to me, that squid proxies are running commonly on this port. So someone may be using an IoT botnet to find open proxies, because there's a number of valuable uses to be able to proxy your traffic through boxes that just arbitrarily allow proxying. So if anybody has any information about it, we'd love to hear your theories, or if you have hard evidence, even better. So that's the show for today. Thank you for joining us. If you'd like to get in contact with us, you can email us at AT&TThreatTraq@list.att.com. You can find AT&T ThreatTraq on the AT&T Tech channel, on YouTube, and there's an audio version on iTunes. You can follow us on Twitter. Our handle is @ATTBusiness. Thank you, Jim, for joining us today. Thank you, Stan. I'm Matt Kaiser. We'll be back next week with a new episode. Until then, keep your network safe.